Good morning, Algebra. Mr. Belky back with lesson 12.6, probability simulations. All right, today we're going to start by talking about theoretical and experimental probability. Theoretical probabilities are determined mathematically about what should happen. For instance, if I wanted to flip a coin, what's the probability of me getting heads? Well, that would be 1 out of 2, right? There's 1 heads out of 2 possible outcomes. So the theoretical probability is that out of every 2 times I flip, 1 should be heads and 1 should not be heads. Okay, that's about 50% chance. Well, let's see. We got heads. So that means this one should be tails. And it is tails. All right. What if I did it again? Heads and heads. Uh-oh. Well, now I've got 3 heads and only 1 tail. So 3 out of 4, or 75% of the time, I've gotten heads. That is the experimental probability. Experimental probability is determined using data from tests or experiments. If I flip this enough times, we would see that it would be close to the theoretical probability, but the experimental probability was 75%. It landed on heads. Okay, so let's take a look at an example here. It says refer to the application at the beginning of the lesson where they're doing some prescriptions. That's at the top of page 677. Okay, what is the experimental probability that the drug was successful for a patient in study 1? So the theoretical probability says it should happen 70% of the time. That's the expected success rate. The condition improved in 61 out of 100 tested, or a 61% success rate. So the experimental probability did not match what the theoretical probability was. Okay. Let's take a look at another one. If we look at example 2, okay, it's often useful to perform an experiment repeatedly, collect and combine all the data before analyzing the results. That's called an empirical study. So you're not just doing it one time, you're doing it over and over and over again, and then you are taking all of the data points and averaging them out. So if we look at the application again at the beginning of the lesson, what's the experimental probability of success for all 3 studies? Well, if you look, the first study was 61 out of 100. The second study showed improvement in 74 out of 100. And the third one showed improvement in 67 out of 100. So the total would be 61 plus 74 plus 67 for a total of 202. But then we need to divide that by the 3 studies. So 202 divided by 3 equals 67.333. So 67 and 1/3%. So in 67 and 1/3% of the time, the condition improved, which is still lower than the theoretical probability, but it's higher than the first one, lower than the second one. It's kind of taking the average. If we just took one data point, here we'd say, oh yeah, it's really effective. Or here, well, it's not as effective as we'd want. But if we take them all and combine them, then we come up with something that would be much closer to the theoretical probability. All right, that's it for this lesson. As always, if you have any questions, please feel free to call, text, email, or join me online tomorrow between 9 and 10 o'clock, and I'll answer your questions in real time. Have a fantastic day. We'll see you next time.